Alright, just going to try and quickly go over some stuff that should have been previously done in high school. So we're just looking at polynomials here. Polynomials are part of the method course, though not explicitly. We sort of just need to know a bit of what they are. So I've written up here the form of a polynomial. So we've got px. Now p, this could be any letter. P's just picked because polynomial starts with p. Alright, and then we have x is our variable. So our variable here, x, and you'll see these are dropping in power. So our first term here is x to the n, then the next term along here is x to the n minus 1. So if this was x to the 3, this one would be x to the 2. And just polynomials are of this form. Now we'll put a few labels on here. So x here, x, and x. These are all our variable. All right, this here is our constant term. So you'll notice it doesn't have a variable with it. Now, our constant term just means that that's a number. Now, the next bit here, we've got this first term here is our leading coefficient. This can never be 0. So leading coefficient. And I'm just going to write here in brackets, a and cannot equal 0. Because if it did equal 0, if we were thinking about this, if this thing here equals 0, this actually would be our leading coefficient and we wouldn't even write it of this form. All right, what else we got? Now, this term here, the letters below here, have the numbers below here, the subscript, have nothing to do with other than linking to our variable. So this, if we had a subscript 2, that means that it's the coefficient of x to the power of 2. That's the only reason we've got that in there. And then n here is the degree of our polynomial. Degree of polynomial. All right, cool. So that sort of covers our definition of a polynomial. Now, most commonly, I'm going to go to the different forms that we see these in. The most common polynomial we would have seen is linear functions. So these are of the form, I've written this here, y equals mx plus c, which is slope-intercept form. Slope-intercept, sorry, my writing. So this m here is the slope, and then the c value gives us our y-intercept. So let's just pick one of these. So a common one for this would be y equals 2x minus 1. Now this would mean if I was going to draw this function up here, all right, it would have a y-intercept of minus 1. So I'm going to use half a square as a unit, and it's got a slope of 2. So that would mean that every 1 unit we come out, we'd go 2 up. We'd come out 1 unit, we'd go 2 up. And this function here would look like something like this. Now, obviously, this is a rough sketch where this would be y equals -1. And you would see here that for every 1 we go across, we go 2 up. All right, common there. All right, quadratics is our next one. A quadratic function, I'm just going to use y equals x squared. If we were to look at this function, it would purely be a parabola like this that goes through 0, 0. All right, there's lots of variations on quadratics. I'm just going to quickly go over the simplest one. A cubic, if we were looking at these, would be a cubic function. A common one would be y equals x cubed, and it has a shape like this. Our final one, a quartic, is y equals x to the 4. Now you'll notice that I'm missing on these ones. I've just left out a lot of these terms. These other terms here in these functions do change the shape of it, but we can get a general shape by using the simplest term, and then from there we can look at it more. This is actually just a refresher. So a quartic looks a lot like a parabola, apart from it goes a little bit more square. It has a low shape and then it sort of curves up more. My drawings aren't the best, but yeah, just an example on that one.